This session refers to the land races and the influence of climate change as related to the world nutrition. With us is Professor Andreas Mammolos, which is Professor in Aristotle University of Thessaloniki in the specialty of ecology, and also Vaso Karnilopoulou from the vector CITO. So, please let's start now our third session.
Good afternoon from me. The first presentation entitled Strategies for Monitoring on Farm Diversity of Landraces for Climatic Change. The first speaker is Eshan Dulo. Please, 15 minutes from now.
Yes. Thank you very much. Can you see me and can you hear me okay? I'm going to try and
Hello, Dr.
share.
Dulo.
Yes. Sorry. Sorry, I'm just uploading my presentation. I'm sorry for the delay. Okay, can you see my presentation and can you hear me okay?
Okay.
Okay, so I would like first of all to thank the organizers to invite me to this meeting. I'm very happy and pleased to be able to participate remotely. So the title of my presentation is going to be about looking at strategies for monitoring of farm diversity of landraces in the context of climate change. I think that if we look at the world at the moment, some of the key global challenges that we are confronted with has been rising levels of biodiversity loss, malnutrition, climate change, and land degradation are the main ones that are really affecting the way that we are able to produce food. But of these, climate change can be singled out as one of the most challenging of those threats that the world is really struggling with to address, because it also affects and accentuates the other challenges like biodiversity loss, malnutrition, and land degradation. Feeding an additional 2 billion people by the year 2050 will need to happen in the context of a shrinking natural resource and changing climate. The IPCC predicts that climate change will reduce agricultural production by 2% every decade, while the demand is going to be increasing by at least 14% every decade until 2050. So this is a big challenge that we are all facing. And we believe that agricultural and tree biodiversity is very much part of the solution on how we can mitigate these problems. Because agrobiodiversity, in particular landraces, and local diversity, is the foundation of agriculture and the source of all current and future crops. It is the source of genetic material which is vitally important for improving our crops for future generations. It can also provide cost-effective and environmentally friendly way to manage pests and diseases and provide options to farmers to manage climate risk. In addition, the local diversity also contribute to health and nutrition by providing diverse nutrient content and dietary diversity from many available species and varieties within a species. And these points has been raised by previous speakers in this meeting. Local diversity can also play an important role in sustaining soil health, food and habitat for important pollinators and predators, which is vital to agricultural production. And lastly, not least, the use of such diversity can offer new income and livelihood opportunities for local farmers. In addition, they are important as they bring the bear to the traditional knowledge and culture, which are often based on those local diversity and how they are used. But the fact is that landrace diversity, agrobiodiversity in general, is in decline. If we look at the recent global assessment of the state of biodiversity for food and agriculture, it states that many of the key components of biodiversity for food and agriculture are in decline. And specifically regarding plant genetic resources, the report mentioned that evidence suggests that overall crop diversity present in farmers' field has declined and that the threats are getting stronger. It further acknowledged that the difficulty in precisely quantifying the extent of genetic diversity within crops, especially in farmers' field. Similarly, in one of the other reports, summary report from IPBES, it also states that globally, local varieties and breeds of domesticated plots are disappearing. So the loss, including genetic diversity, really poses a very serious risk to global food security by undermining the resilience of agricultural system to threats such as pests and diseases, and in particular to climate change. Now, monitoring varietal diversity, monitoring the changes in genetic diversity of crop plants, over time at national, regional, and global level is proving to be really extremely difficult. And yet, there is no systematic global monitoring system, which is internationally agreed, in place to do that. Some of the key constraints that we face is that the number of landraces are very high and they are spatially distributed. And there is no globally accepted methodology for monitoring landrace diversity. The lack of data at global level, regional level, and in many countries are also a major constraint in establishing baselines against which we can monitor trends in landraces. And also the fact that landraces are constantly evolving with time is another big constraint. Now, the question now is how do we measure the diversity of varieties on farm? Now, for decades, Biodiversity International, its predecessor, IPCRI, has been working on the scientific basis for on-farm conservation and have been defining three critical concepts of diversity to estimate the level of diversity on farm. These include the species richness in terms of the number of traditional varieties that one can find on farm. And the other one is evenness, which is the frequencies of different variants that is being grown on farm. And a third critical element is the divergence, that is the probability that two randomly chosen households within the same community are growing different varieties. Now, with these measures, it is possible to come up with a good estimate of varietal diversity that is maintained on farm. However, for an accurate estimate of this diversity, a correct naming of local varieties is needed. Often there are many inconsistencies in the naming of those varieties. Colleagues like Brown and Hodgkin and Jarvis and others have shown that, discuss how farmers recognize distinct varieties based on agro-morphological or ecological, adaptive and use qualities, and how farmers are naming those varieties. But again, some of the same farmers' named varieties are not genetically distinct, and in contrast, different farmers' named varieties are genetically similar. So these really pose us problems on how we can get accurate measures for the numbers of varieties. Now, a prerequisite for monitoring diversity is that we have trend data with the timeline comparison in the past. And this is often being challenged by having incomplete baseline information. One option is to identify contemporary landrace hotspots, undertake baseline studies in them, and develop a network of observatories or hotspots. These would then provide solid, robust baseline that can be used to track the conservation status and the dynamics of those landraces. Toolbox for complementary contemporary methodologies for assessing these has been developed by the CGIAR, for example, by the CGIAR research program on rooter and tubers and bananas, and for long-term monitoring. But if we look around in the world, there are very few examples on how systematic monitoring has been done. We have, for example, the implementation of framework in the hotspots initiated in potato in the Andes. And there is also the example that Raichi et al. Has presented earlier in the previous session about establishing a regional network of landrace hotspots in Europe with about 100 hotspots and other localities of Europe. But these are very good examples, but they are very few globally. I would like to talk a little bit now about an experience that we have been doing in India as part of a United Nations Environment GEF project, mainstreaming agricultural biodiversity conservation and use in the agricultural sector to ensure environmental services and reduce vulnerability in India. We carry out baseline surveys in 7 states in India using the 4-cell analysis approach to assess varietal diversity in farm in 5 contrasting agroecologies regions in India. Now, in each site, we carry out focus group discussion with farmers, which are regardless of ethnicity, gender, and castes. And they were identified in collaboration with local village leaders and local extension workers, and based on knowledge, not farmers' knowledge about crop varieties in those sites. We use the 4-cell method to collect information on crop varieties which are grown in these study sites and their status and trends. Before listing the varieties, we collected we collectively discussed with farmers the threshold for defining, what are the few and large household means and how small and large area means. And collectively, farmers agreed on a threshold value of 10% to define these various categories. Then for each farmer listed crop varieties that are grown in the household, they would assign each of those to those different quadrants. Farmers was also asked about varieties that they grew over the 10 past years and that was no longer grown and the reason why they were not grown. And for each variety, we also collected information regarding their major use and variety type, whether they were Landraces or improved, and how those varieties changed over the 10 years. Now, in this study, we also developed a method for calculating a varietal threat index using the 4-cell analysis at different geographical scale to monitor changes in varietal diversity that we were able also to compare between areas. We used a modified methodology of the IUCN red list. So we group varieties in 4 categories, which are analogous to the IUCN red list categories, depending on the spread and on the abundance of those varieties. Thus, varieties that were grown by few households and on small area were considered as threatened. Those that were grown in large areas and on few households and large areas was near threatened. Those that were grown by many households on small areas was considered as vulnerable, and those that were grown by many households and on small areas were of the least concern. And varieties that were not grown over the past 10 years were considered as being lost. And based on this information, we were able to calculate a varietal threat index based on the maximum threshold and the total threshold. And the index would have a value between 0 to 1, 0 where all the varieties are of least concern, and 1 when all varieties would have been lost. Now, our results are based on this showed that there were, in India, in those sites that we worked with, there were a total of 38 crop species and 472 varieties that were grown, of which more than 50% were rice varieties. Crop richness was measured using number of crops at the species level, whereas the evenness was measured within and across the species. Our results indicated that in some regions like the Eastern Himalaya and the Eastern Plateau and Hills were characterized by very low species richness varieties, whereas the Central and other Western regions has higher species richness and was more significantly more evenly distributed varietal diversity, suggesting the presence of many more varieties across crops. Now, in this figure, you can see the varietal distribution by threat levels, by major use level, and area change during the 10 past years, and also by varietal type. Now, it shows that more than half the varieties listed across the study are actually threatened or under loss category. The threatened varieties are mostly used for consumption, are declining in cultivated areas, and are Landraces. 67% of the or above of the Landraces are vulnerable, near threatened or threatened and lost. Varieties of least concern are mostly increasing in areas where they are used for multi-uses and predominantly improved or released varieties. This figure shows the varietal risk index at the agroecological and site level index. It shows that across the western regions, region reported lowest threat of landraces, although the number of reported varieties are extremely low, suggesting that landraces are doing very well there. In contrast, in other sites in the Himalayan region, they report a relatively large number of landraces with a high threat index. So in conclusion, ladies and gentlemen, I think we've been able to show how climate change has been able to be singled out as one of the most challenging threats for agriculture, and that agrobiodiversity can be seen as being part of the solution. We have also seen that recent global assessment of state of biodiversity in the world is showing a decline in agrobiodiversity, and that there is an urgent need to mainstream a framework of global to local framework for a systematic monitoring of land races in hotspots area. Our study in India has really given you is able to show a hotspot, a snapshot of a varietal diversity across different states and different agroecological regions in India. The methodology we developed on the varietal threat index is a useful one that can be used to set a baseline of the status of landraces against which we can assess and monitor genetic erosion. But still, the study has shown that there are still significant diversity grown in different regions. But on the other hand, that there is still more than 50% of farmers' varieties that are being threatened. So with this, I conclude my presentation, and I'll be happy to take any question. So thank you very much for your attention.
Thank you very much, Eskan Gulu, for your interesting presentation.
And now, after Biodiversity International, we have a Food and Agriculture Organization from Rome. We have a very interesting topic also, Landraces Diversity for Advancing Food Security and Nutrition. We have a group, Bonnie Furman, Arshia Noorani, and Chikela Mba. Welcome to the floor.
So I'd like to thank you for the invitation. As I've been introduced, I'll be discussing landrace diversity for advancing food security and nutrition, but this is going to be a bit of a more broad view of the topic. And there's going to be, in the introduction, some synergies with Dr. Dulo's presentation, which really can't be helped. So this is an outline of my presentation, and after a brief introduction of the topic, I will touch on the importance of conserving and sustainably using local crop diversity to address malnutrition and insecurity. I will then give you an overview of some of the relevant tools, or an overview of some of the relevant policies and initiatives developed over the last 30 years that aim to conserve and use this diversity. And finally, I will present some of the relevant tools and guidelines developed by FAO to strengthen capacities in countries for conserving and using crop diversity. So we begin with the highlighting that the world is not on track to achieve Sustainable Development Goal 2, zero hunger by 2030. In fact, in 2019, close to 750 million people, about 1 in 10 people in the world, were exposed to severe levels of food insecurity. Should recent trends continue, the number of people affected by hunger would surpass 840 million by 2030. And And in spite of global efforts to reverse this trend, it is now projected that around 660 million people will still be affected by hunger in 2030. As Dr. Dulo mentioned, one of the key solutions to addressing hunger and malnutrition, as well as improving livelihoods, is the conservation and use of crop genetic diversity, which of course includes farmers' varieties and land races, which is the topic of this very interesting conference. Unfortunately, this important diversity is under threat. Some of the key threats include urban encroachment on farmland, unsustainable use of natural resources, and the promotion of genetically uniform varieties which replace local varieties and land races on farm. The changing patterns of human consumption, environmental changes, including climate change, the emergence of novel pests and diseases, and limited legislation and policy frameworks all threaten local crop diversity. Compounding this situation, the narrow genetic base of crop production systems is of major concern. Here you can see that of the approximately 390,000 vascular plant species, only 6,000 have been actively cultivated. Further, we have analyzed that in 2019, less than 200 crops were used for global food production, and even more narrowly, only 9 of them: sugarcane, maize, rice, wheat, potatoes, soybeans, oil palm fruit, sugar beet, and cassava accounted for over 66% of all crop production and 53% of global average daily calories. So you can see that the fragility of crop production systems, it's quite clear. A significant amount of crop diversity, particularly farmers' varieties and land races, is only maintained in farmers' fields, orchards, or home gardens. Enhancing this crop diversity leads to a resilient crop production system, as we just learned. It also reduces vulnerability to both environmental and economic shocks. Local crops and varieties are potential sources of traits for crop improvement, especially for developing varieties tolerant to biotic and abiotic stresses attributed to climate change. Broadening the inter- and interspecific diversity of crops cultivated also contributes to diversifying of diets through increasing the diversity of food consumed, as well as increasing the quality through breeding initiatives to develop nutrient-dense crops varieties, for example, through biofortification. The diversity of crops and varieties maintained on farmers' fields must also be backed up ex situ in gene banks to ensure their conservation in an effective manner in case of loss on farm. A significant proportion of farmers' varieties and land races is concerned in the more than 650 gene banks worldwide. This map shows the gene banks, current gene banks in the world, majority of them, and the larger the circle, the larger the size of their collections. This complementary ex situ conservation of crop diversity is essential for present and future global food security. Diversity conserved in gene banks can be assessed and made available to researchers and to plant breeders. The development of farmers' varieties and land races is commonly undertaken through participatory plant breeding, which aims to bridge the formal and informal seed systems. Demonstration plots in farmer field schools are utilized to increase farmers' awareness of the quality of varieties and seed produced and to support adoption. Community seed banks play a crucial role in these activities. These informal, locally governed institutions increase access to diverse and locally adapted crops and varieties through seed collection and distribution, seed production of improved local varieties, and education and awareness activities. Community-based small-scale seed initiatives are often linked to community seed banks and play a vital role in varietal improvement, access to quality declared seeds and planting materials, maintenance of crop diversity for food security, and positively contribute to national breeding programs. Local crop diversity is also an essential resource for breeders to improve new cultivars with desirable traits. Crossing high-yielding varieties with lower-yielding resilient ones can reduce genetic weaknesses through broadening the genetic base of cultivated crops and varieties. It is very important to measure, evaluate, and record crop characteristics in information systems. Making this information available to all relevant stakeholders increases their usefulness in addressing malnutrition and climate change, among other issues globally. It is not enough, however, to simply make information available. Evidence-based policies and frameworks are needed for increased impact. Recognizing the need for this, diverse initiatives and policies and global frameworks have been developed and implemented over the past 30 years. I will give a quick overview of some of these to highlight the increasing awareness for conserving and using crop diversity. One of the first major initiatives was the International Undertaking on Plant Genetic Resources in 1983. It was a momentous recognition of the importance of these resources. The undertaking aimed to, and here I will quote from the actual document, ensure that plant genetic resources of economic and/or social interest, particularly for agriculture, will be explored, preserved, evaluated, and made available for plant breeding and scientific purposes. The undertaking also laid the groundwork for future developments of frameworks for crop diversity, including the Global Plan of Action for the Conservation and Sustainable Use of Plant Genetic Resources for Food and Agriculture, adopted by 150 countries in 1996, the International Treaty on Plant Genetic Resources for Food and Agriculture that entered into force in 2004 and provides a legal framework for the exchange of plant genetic resources and benefits derived from their use. The second Global Plan of Action in 2011, which I'll talk a bit more of in just a second. The Cordoba Declaration, which emphasized the importance of underutilized and promising crops at the international level, and the adoption of the 2030 Agenda for Sustainable Development by 193 member states of the United Nations. The second Global Plan of Action, or the second GPA as it is known, is the current internationally agreed framework for the conservation and sustainable use of plant genetic resources for food and agriculture. It was endorsed by FAO's member countries in 2011. Implementing the 18 priority activities of the second GPA contributes directly to the achievements of Sustainable Development Goal 2 on zero hunger and several of the other 16 SDGs. Its implementation is also aligned with FAO's vision of sustainable, inclusive, and resilient food systems. The second GPA addresses in situ conservation and management, ex situ conservation, sustainable use, and building sustainable institutional and human capacities, including promoting farmers' varieties and land races, increasing regional and international cooperation, including research, education, and training, and enhanced institutional capacity, and developing and implementing evidence-based policies to promote and improve the effectiveness of on-farm conservation, management, improvement, and use. For maximum effectiveness, activities that address conservation must be linked to those activities concerning plant breeding, which in turn must link to seed delivery systems. This continuum approach is also important for enhancing crop diversity on farm and will require the close collaboration among stakeholders, such as extension workers, researchers, breeders, seed enterprises, and farmers. In order to support the conservation and sustainable use of crop diversity, FAO has developed a number of relevant tools and guidelines. These aim to strengthen national capacities, their genetic improvement, and their delivery systems. The tools and guidelines also promote the cultivation, consumption, and marketing of local crops and varieties They also support the development and implementation of policies, as well as fostering partnerships and strengthening capacity. So I will now just provide a brief description of some of our main tools and guidelines developed by FAO. The guidelines for developing a national strategy for plant genetic resources for food and agriculture were developed to support countries in preparing national strategies for PGRFA, or plant genetic resources for food and agriculture. It's a long name, but it's what we use at FAO. These take into account each country's needs, capacities, and constraints. The voluntary guidelines for the conservation and sustainable use of farmers' varieties and land races were published in just a couple of years back, support countries in enhancing the diversity of crops and local varieties cultivated by farmers. They serve as reference material for preparing a national plan for the conservation and sustainable use of farmers' varieties and land races. They are a useful tool for development practitioners, researchers, students, and policymakers who work on the conservation and sustainable use of these valuable resources. Although not depicted here, the sister publication is Voluntary Guidelines for the Conservation and Sustainable Use of Wild Relatives and Wild Food Plants was also published. With regard to ex situ conservation, we have developed the gene bank standards for plant genetic resources for food and agriculture, which set the benchmark for current scientific and technical best practices. These standards support key international policy instruments for conserving crop germplasm in gene banks. The practical guides for the application of the gene bank standards are companion volumes to the gene bank standards. They present the action steps of the gene bank's workflow in a sequential manner and provide guidance on the complex steps and decisions required when operating a gene bank. These practical guides, 3 of which will be published very soon, for seed gene banks, field gene banks, and in vitro conservation. Other relevant tools and guidelines include the Voluntary Guide for National Seed Policy Formulation. This guide addresses seed policies and describes the participatory process of the seed policy formulation. The Quality Declared Seed System consists of guidelines and protocols that aim to assist small-scale farmers and relevant stakeholders in the production of quality seed, and its partner publication, the Quality Declared Planting Material, which follows the same principles of FAO's Quality Declared Seed System publication. The Seed Toolkit, which are 6 detailed manuals, support practitioners along the entire seed value chain to acquire the knowledge and skills needed to deliver quality seeds and planting materials of well-adapted crops and varieties to farmers. And finally, just last year in March 2021, FAO held the first International Multi-Stakeholder Symposium on plant genetic resources for food and agriculture. This technical consultation brought together experts, practitioners, and other stakeholders from around the world to contribute to an increased understanding of the role and importance of in situ conservation of crop wild relatives and wild food plants and on-farm management of farmers' varieties and land races. We are now in the process of planning a number of technical webinars to continue to raise awareness and share knowledge on wild and cultivated crop diversity. And we hope that this is the first of a long number of international symposia on these topics. And with that, I thank you. Sorry.
Thank you very much, Bonnie Furman. Thank you very, very much. And we will
I'm
continue.
Trying to stop sharing.
Yes.
Okay.
Thank you for the time being.
The next
We'll come back to
presenter
you.
is Monica Mesmer from European Consortium for Organic Plant Breeding. The title of presentation is Participatory Breeding to Enhance Utilization of Landraces. Monica, please.
Do you hear me?
Yes?
And do you see the presentation?
Yes?
Okay, then welcome everybody, and I'm very glad to be here to give a presentation to this very important scientific conference. And I also wanted to thank very much Kostas, who is also a member of the European Consortium for Organic Plant Breeding, who really helped me to get to this point and to invited me personally to give here a speech. Just wanted to start my talk a bit about what is organic plant breeding, since we have a consortium for organic plant breeding. So there has been a position paper that have been developed that claims that the organic plant breeding need to be adjusted to the whole value chain, and that we also, besides all the technical issues, we also have to respect the intrinsic value of the living beings. That as a consequence of that, we have defined certain criteria for which we use if a new breeding technique is adequate for organic plant breeding or not. And one of the main part that came out was that genome and cell is the smallest unit that actually a plant can recover from. So it's an indivisible unit, and no technical or physical intervention should be done below the cell level. It's also important to maintain the original reproducibility of a plant according to the species way. There should also be no legal or technical barriers to restrict the use of a cultivar by other breeders. So we really think that's very important to stay and keep with the breeders exemption that we have in the European plant variety protection. Also, the natural crossing barriers should be respected, so that also excludes, for example, cell fusion between different plant species. And we're also aiming for open pollinated variety as an alternative to the F1 hybrids that are now really taking over the seed market, as we also think it's very important that the farmer has the opportunity to produce its own seed, so that we also can contribute to the seed sovereignty of the farmer. As pointed out by Ricardo, it's also quite important that we have a transparency on the seed techniques used and how the cultivar has been developed, as in the organic sector in general, the processes are as important as the product that derives from the process. And due to that reason, we also deny the patenting of living organisms, as this really restricts the accessibility of the seed for breeders, but also for the farmers as a whole. Another criteria is that the organic breeding need to be done under organic conditions, and there are also socioeconomic criteria that there should be fair and participatory breeding, and that there should be also diversity of very different breeding programs. This is just as a sideline. There has been an international position paper on new breeding techniques from the umbrella organization IFOAM that was in consultation in 2017. There is the list of all the different breeding techniques and how the organic sector would allow it in organic production or in organic or animal plant breeding. And then we also had a dossier where we described the different techniques. I don't show this, as we already heard about this, but just coming back, that diversity is really the basis of our food, and therefore it's very important that we really take care of the resilience and the resources to use the efficiency also in the farming systems. And we very much promote also participatory cultivation and participatory breeding, as this is a really an alternative to increase the agrobiodiversity, because there we really select for local adaptation. And maybe the figure can demonstrate the main difference. It's like on the normal side, we have the genetic diversity that it's kept in public or private breeding programs, that they create new genetic diversity, and then during the selection process, they will select the best cultivars under given conditions. Then the seed of the cultivar will be multiplied after the release, and then it will be propagated and eventually arrives to the farmer's place. But our idea is that really the farmer should be in the center of the participatory breeding, and that all really should work together, the breeders, the agronomists, but also the climate specialists who can predict how the weather will come in future, but also molecular biology And quite important are also the traders and processors, as this is very important at the very beginning to also know what kind of marker we want to produce. And the idea is really to build capacities that the farmers stays or becomes again a breeder himself, so that he is not dependent from seed that comes from global sources. For that, the principles for participatory breeding is that it's in general decentralized, and it really focuses on the local adaptation, also for local markets, and supporting the diversity. And with this, it also strengthens the rural regions. And this, of course, often starts with land races. They're also very important to identify or selected by the farmers because they expect to select more robust genotypes. This can be done by mass selections within a population, but it can also be used to make crosses of land races or crosses of populations to develop new genetic diversity that then adapt and adjust to the local conditions. And that means that the trials are really moved away from the research station to the real target where the farmer is growing the plant. And it represents, therefore, many different conditions that are important for the smallholder farmers. And also we have seen that it's quite important that who we involve. So it's not only important that the farmers are involved, but also the wife of the farmer need to be involved because she's the one responsible for the food, and she has different demands for cultivar when it comes to processing of the food or the taste of the food or the storage of the food. And of course we have to consider the local market from the very beginning and really have to make shared decisions between farmers, breeders, processors and consumers. And also, as we discussed beforehand, I think it's very important that there is a common ownership of the cultivars and also of the ownership of the co-creation of knowledge that is developed in the scope of some common activities on that side. And with these initiatives that are in generally very small initiatives, but there's a large number of initiatives, we will create and increase the genetic diversity that is available, and that will be a very important supplement also to what is on the on the seed market, and depending on the country, that might be the only source for the farmers to get good quality and adjusted seed. This is just a different level of participation, how it goes, that there is like, it can be that researchers manage just on an on-farm trial, but everything decided by the researcher. It can be that the researchers consult the farmers what they should do and what is most important. It can be that different tasks that are shared, that some are done by the scientists and some by the farmers, but there are also quite a number of initiatives that totally managed by the farmers where no scientists involved. And we have seen that quite important is if there could be a collegial models of collaboration where the collective decision is made in a group process and where also the responsibilities and the accountabilities are shared. And most important of all the initiatives that we have looked at and all the case studies is that you really need an enthusiastic facilitator, the one who really follows up the process, who is the one who moderates between the different actors and the different interest groups, and also to make sure that they're not, that if there is different interests or conflict of interest, that we still find a common solution to drive this process. This we have experienced is not happening alone. It really needs somebody who is independent and can move that forward. We have, I just want to give some results of the live seed project that we have been involved the last 4 years, where it was about boosting organic seed and plant breeding across Europe, where we looked at the different topics from policy, basic research, but cultivar testing, market analysis, and communication. And one of the big part was really breeding for diversity, as with a higher diversity, we'll also have a higher resilience. There have different concepts been developed how to improve the diversity in the field, and also on the farmer level. So it's on one side, it's on the landscape level, how many different crops are grown. Then also on the farm level, also how many different cultivars a single farmer is growing. But then also you can have genetic diversity in the field when we, for example, look for composite cross populations or dynamic populations that are phenotypic and genotypic heterogeneous, that can adjust to multiple stresses in the field and make an evolutionary process. We also looked at cultivar mixtures and also for species mixture. As in the forage crops, it's quite common to use species mixture, as we have been shown for many decades that there the productivity and the land equivalent ratio is higher than if single crops. And the same, it's also true for arable crops, but it has not been applied so far, as in the past everything has tried to make things more monotonous and more easy for mechanical development. But now with the new techniques and the smaller machines and maybe also robots, it will be much more possible to have also mixed cropping in the field in different combinations. To work on that. And here it's just an example of different methods how to develop genetic diversity and these heterogeneous populations. On the left side, it's so-called dynamic population that has been made by mixing different cultivars that are grown together in one field, and then due to depending on the outcrossing rate, there will be some outcrossing happening, and therefore new genetic diversity will evolve, and there will also be a shift of the different alleles that are present in the population based on the environmental stress. On the other side, we also have been working quite a lot on so-called composite cross populations, where the different cultivars have not only been mixed, but they really have been crossed in complex crosses, in single crosses, followed by double crosses and four-way crosses, so that really all the genotype are really mixed within the progeny. And then also this grown together in the field. And this also will change. They will become more homozygous over the time, but we will also observe that there is some shift in gene frequency. And there, of course, we can do on one side only the selection of the location, but of course you also do human selection depending on what trait you're looking for. For example, when the baking quality is an issue, or when, for example, the harvesting time, you have to make sure that everything can be harvested at the same time. This is another just a practice how this has been practiced. For example, with farmers' land races from tomato. We already heard from Jaime in the situation before. We also worked a lot with land races from Spain and Italy. But here we did not try to develop a hybrid, but we did try to develop open pollinated populations and also composite cross populations that can then be multiplied also by the farmers, so that he doesn't need to buy hybrid seed each year. This is another concept that I think it's quite important when we talk about how we can improve the utilization of land races. There is in the United States a culinary breeding network that involves farmer, breeders, cooks, food professionals and consumers. And especially the cooks are really some influencers that if they show quite a big interest in traditional vegetables or traditional crops or different traditional land races that have a special shape, a special taste that can be used in the kitchen. And so they actually meet together with the farmers and the scientists, and then they do the degustation together, and so that they really can develop something that is unique, where you then also can find a market to sell the land races. And another thing I think what is quite important in order to make things more accessible to farmers or to increase the usage is also if we can develop some digital tools where the data of the different collections and descriptions of the land races are shared. There is a platform in the United States that they have developed such a digital platform that the gardeners, for example, can access with their mobile. They can enter, they test different cultivars, they enter the rating in their mobile, and this will go into a common database where then all single statistics can be retrieved by the farmer. They can also use the tool to make degustation, so that you have like on the site already the results what would be liked by consumers. And we are at the moment in the process that we want to implement this tool also under European conditions in the new Horizon Europe project live seeding. We wanted to see how this can be implemented, and they have already, Redes Rurales have already started to do some trials and implementation in Italy with that tool. And last but not least, I think it's also when it comes to land races and the importance, we also do not need to forget that land races might have also a quite different microbiome than modern cultivars that have been bred. And in the recent years, it has been become clear that the microbiome, for example, human gut, is very important for our health, for our immune system, and it's said like the gut is kind of a second brain that is interacting with our brain, and therefore it's very logical that a plant that is fixed in the soil has even much more interaction with the microorganisms. And it's just started now that studies looking how this can be utilized in breeding, and how we can see that the plant has a more balanced microbiome. And what you see here, there was a study done in the Netherlands where they checked what is the difference in the root morphology and also in the rhizosphere microbiome of the common bean, Phaseolus vulgaris, and they checked on one side the land races that are the green dots that you see on the right side versus the modern cultivars. And they looked for the different bacteria that they could identify in that community. And what you clearly see is that when you look at the green one, that it's more balanced. So you have more microorganisms with a small frequency. But if you look at the modern cultivars, you have some very big red dots. That means that they were in very high frequency. And there you also see that there is quite an unbalance. So I think we also, it's very important to have the in situ cultivation of our land races at the places of origin or at the hotspot of diversity, that we also maintain this diversity. And just wanted to show that I'm working also at Fiebel, so there we also have a new project on the consumption of resilient orphan crop and products for healthier diets. And the main aim is to improve food security and the nutrition of smallholder farmers in Chad, Niger, Tanzania, and India. And the major focus is to really make sure that conservation varieties of farmers and land races are conserved and utilized, and then can also be used to develop a business. And for this, we followed the so-called push-pull policy strategy. On the one side, to really bring from the economic side these things to make the seed production and make seed available, but also we would need to work on the market side to have to create awareness and create a demand from the consumer. And of course, we also need policy that are enabling this part. And they're just these are the different parts that we're looking at with the seed system. For example, we would also do the inventory, what is available. We also made a survey how many different crops the farmers are using. And when we were quite shocked that when we looked at neglected species, the farmers only on average use 1.1 different variety. So there we might have lost already quite a big number of land races that need to be done. And we also have to make sure that when we want to to maintain the land races, that we have to work with peasant and community seed systems, but we also have to make sure how the seed system, how we can support the informal seed system, and how we can create also a marketplace and a market development so that it also becomes attractive for the farmer to produce seed not only for its own but also for his neighbor or maybe for the region to work on that. And in order to prove that, we need to have the right seed policies, but also we need to have quite a focus on the food policy, as it's not sufficient to produce calories, but we have to make sure that we are also producing the balanced nutrients that we need for human health. And just here to mention the policy part, we are very happy that at the European level with the new organic regulation, we have now new cultivar types have been allowed, that now the organic heterogeneous material that are genetically diverse and phenotypically diverse and would never pass the uniformity criteria for the variety release, that they are allowed to be, the seed of them are allowed to be marketed in the European Union with a very small administrative burden. And we are also working at the moment on the temporary experiment how organic varieties suitable for organic production that in general also have a higher diversity also can enter the formal seed system. I think this is something we are also very happy to follow up the seed legislation and the changes that are going on there, and hope that that might also go in a more flexible direction. And just to summarize, I think it's the land races are very important for participatory breeding. They're, in many cases, they're the most important source for the genetic diversity. They're very important for the local adaptation and the decentralized autonomic seed production on the local area. And it's also important for them to have special nutrition or taste, but also for the cultural characteristics, they might be quite important depending on the region. And for many neglected crops, there are only land races available, and because also not many of them are in the gene banks yet, because the gene banks also have focused on the main crops, and there we're really in danger to lose the land races if we're not doing a fast action. And for that, I think it needs enabling frameworks for diversified seed, but also for the food products that are based on this neglected crops and the land races in order to improve the agrobiodiversity as a whole. And for the organic sector, it's quite clear that we need different types of cultivars. We need also homogeneous cultivars, but we also need organic heterogeneous material. We need conservation varieties, amateur varieties, or organic varieties, if we have really a plurality of different farmers and different situations and different markets. And for each situation, you would need different cultivar types, and there we hope that the new legislation would allow more flexibility in the future. And with this, I thank you for your attention.
Thank you very much, Monica.
And now we go to questions. I think we don't have any ones from Slido. So what about the floor from this? Do we have any questions from this room? I have one for Bonnie Furman from FAO. She referred to a very interesting point of the very narrow genetic base of our food. And she referred to that genetic base talking about number of species. Now, I was wondering, is there any reliable information about the very narrow genetic base of the seeds in the catalog, in the Common European Catalog? There are many reports that they're very much, this is within each species. There are reports that they are very related to each other, so that they only cover a very small percentage of the real genetic base of the species. And I was wondering whether FAO has such information? Thank you.
I think at that level, we do not, unless it's reported by countries specifically. We have Dr. Dulo mentioned the monitoring, but we have a different kind of monitoring system, whereas more of a general monitoring system that we do every year, but then also every 10 years for the state of the world. And one of that is to ask countries report on the different indicators of the second global plan of the global plan of action, or at this point, the second global plan of action. And one of the questions is on their inventory of landrace and varieties found on farm. In terms of the genetic diversity or actual landrace diversity, other than that, I don't think that we do. Ehsan, can you answer that question a bit better than me? Because you have much more experience at that level, and you worked at FAO as well.
Thank you, Moni. Thank you for the question. I think it's a very important question. And as Moni says, the information that has been gathered about this through the reporting mechanism established at FAO and views is all we get, but there is very few information about that. And that is the big problem, big challenge that we have, is that the landraces, there are plenty around, as I said, and others have said, it's widely distributed, and the work that the other presenters has presented is really fantastic. But they are not documented, they are not centralized. We don't have country catalogs for those landraces. I think this is what we need at this time. We need to really establish a mechanism for giving incentive to countries to develop these landrace catalogs. And I think the presentation of Raji for the Farmers' Pride project has been in that direction. And you could see how much diversity exists at the European level. The map he showed is fantastic, but you could see also in that map that there's a lot of gaps because countries has not been participating in this, so there are still gaps to really get the big picture about the extent of diversity of landraces that we have. Thank you. I don't know whether Monica, who is a bit more experienced on.
No, I think you're right, Ehsan, and I think that, it definitely would be a direction to go. And one of the issues that, just from the perspective of the country reporting, is that countries sort of are asked to provide lots and lots of information over and over again through these processes at FAO, which they're very important processes, and governments are encouraged and to some extent obliged to participate. But that said, I think that there does need to be an effort, at least at the national level, to provide these. And this is something that is I mentioned the voluntary guidelines for the conservation sustainable use of farmers' varieties and landraces. And this is discussed in there as a mechanism that's very important. And so having countries utilize these guidelines and developing these national plans is a first step.
Thank you,
Ehsan.
I'd just like to add that in this process of developing the next round of the State of the World report, we see that there's a lot of countries that have done inventories, but they are done really on an ad hoc manner or funded by particular projects and particular regions. So we don't really have an overview of the diversity at the national level even. So that's something we need to address in the future. Thank you.
Thank you very much. I think we should demand more transparency in breeding. We should all demand that. So thank you very much for this session. It was very, very interesting. And we have a light break, lunch break now. Thank you.
Thank you very much for inviting us.
Yes, thank you for the invitation. Bye-bye.
Thank you.
Thanks a lot.